Hey everyone, welcome back. We'll try and get through what we did in class today in our usual 10 minutes. It was one of those 4-day weeks because we had, of course, Labor Day off on Monday. It's always weird how the 4-day weeks sometimes feel a little bit busier than a 5-day week when it comes to school. So let's jump on in and see what we did today. If you look at what we started with in this class right here, the brain pop that's up on the board, there's a good one out there on 9/11. Usually with brain pop you need a subscription, but I'm pretty sure they make this one available to everyone. So it's really worth checking out. It's a very, very good one. And I recommend it. 9/11, September 11th is my nephew's birthday. My nephew Trey Forbes. I mentioned him for a reason. I'll come back to him in just a second. But if you check out the brain pop that's out there, Mr. Westbrook, across the hall over there doing social studies, used the CNN 10 today, which is a very, very good one as well. Those are also out there for use, and you can check them out on your own. And the reason we started with it was for a number of reasons. For example, social studies, and just across the board, we are currently, as a country, as the United States is trying to pull out of Afghanistan after a 20-year-long conflict there. It's important for students to know that these things don't just happen overnight. This is something that's been going on for quite a while. My own nephew, Trey Forbes, served in the Air Force over there, and he was at an air base over there in Afghanistan. And I mention that because the implications of things that happened maybe 6 or 7 years before some of the students in this classroom were born really still do have repercussions today. It's really important that students understand this. We also want to talk a little bit about the Twin Towers. They do a good job on the brain pop up here showing the Twin Towers, but they do it in a very gentle, well, as gentle as they can be, a cartoon type of form. It doesn't show footage from the day is what I'm trying to get at. And when you look at the science that we end up going into here, it actually has implications for that. And it doesn't take very long for you to go on to something like YouTube or websites and find out all kinds of ideas on, oh, well, I wonder if the Twin Towers came down because of explosives or something like this. One of the reasons that we have science classes to really look at things with a critical eye, dispel myth and conspiracies and things like that, and say, okay, what is really going on in terms of evidence? As a matter of fact, today's lab, which I'll get to in just a second, is all about gathering data and checking evidence. So in as sensitive a way as possible, we also want to address, shining the light of science on things that are out there that might be misinformation. So that's where we're going to jump into today. We watched the brain pop. The World Trade Centers in engineering were made of steel. And like most modern skyscrapers, all modern skyscrapers, made of steel. And if you look at the periodic table that I've got across the room, you're not going to find steel on the periodic table. What you will find is iron. Element number 26, interestingly enough, tie in with last week, that is the largest element that is made inside our sun while it's still our star. When stars blow up, then they make the large elements past number 26, past iron. So element number 26 is iron, and we found that if you add a little bit of carbon to iron, not much, 1 or 2%, you make steel, you make an alloy, which is a combination of two things that make the finished product stronger than it would be on its own. In other words, just building with iron on its own wouldn't be practical. It bends too easily, things like that. Put in too much carbon, it gets too brittle. But if you get the alloy just right, you can make it so that it's a very good building material. That's what the World Trade Centers were built out of. Concrete, steel, and we'll come back to that in a second. As part of the 7th grade standards, we also go through the states of matter. Now, in all our textbooks, we've got the classics: solid, liquid, gas, solid, liquid, gas. You've heard that probably a million times. In a solid, the molecules or atoms are kept in very close quarters. In other words, it's a little bit like linking arms. They are basically kept in position next to the atom or molecule that they're next to. They are still moving. It's important to kind of remember that they're still jiggling around. They're still moving. This goes back to our unit on Brownian motion when we talked a little bit about that. Atoms and molecules never stop moving, but they're locked in position for the most part. However, when you add a little bit of energy to that, they break the bonds with the adjacent molecules or atoms, and they can move around more freely. The best example you can give, because we talk about water in here a lot, is ice, liquid water, and of course steam. When you get down to the steam level, you are talking about molecules of water that have so much energy, they're in the gas state, A lot of times we call clouds, the gas state of water. It's not quite true. That's a misnomer. We always say that, like, for example, you take a hot shower and the bathroom gets steamy or something like that. It's not really steam. Steam is a gas state that you reach when you get up to 212 degrees. It's scalding hot. True steam is invisible. You see water vapor like in bathrooms and clouds. Those are actually little tiny water droplets. Steam is when you get to the gas state and you add a tremendous amount of energy to it. And then finally, over here, just a little note, more to myself really, that's why it's in cursive, is when we talk about plasma is yet another state of matter. If you saw the lightning storm around here last night, you didn't see plasma directly, but you saw something so hot that it can make plasma. That's what lightning does. If you check out my pointer I always use in the old Star Wars science fiction movies, a lightsaber is supposed to be a plasma weapon. If you're looking at plasma, you're talking about a state of matter where the atoms and molecules get pulled apart. Now, not the nucleus of the atom, but the electrons get stripped away. What you have is the nuclei of atoms, protons and neutrons, and free electrons moving around with such high energy that they don't combine to form a true atom, protons, neutrons, and electrons, until the energy levels come down a little bit. But we're going to do a totally separate lesson on plasma a little bit later. I just wanted to touch on it because it is one of those other states that we talk about. Moving on from there, we did an experiment in class today. See if we can get the whiteboards working just right. The experiment in class had to do with gathering data with a pendulum that looked something like this setup right here, where we had a string and a weight hanging from the end. And the students were challenged to do this. We changed the weight at the end of the pendulum. And first, they were to be able to make a prediction. They're asked to make a prediction. If I change the weight while keeping this control variable, the string length, the same, what will happen to the period of a pendulum? Now, the period of a pendulum is, when you let it go, it is one complete swing out and one complete swing back. So that's the period of one swing of our pendulum, if you will. And when we're looking at the period of a pendulum, we want to see how does the mass at the end of the pendulum affect the period. We started with a 6-gram mass, then we doubled it, and we added another weight to it. We went to a 12-gram mass, and students were asked to predict. What I believe they're starting to check out, and if you're watching the YouTube video classes, you'll know ahead of time that the mass at the end of the pendulum shouldn't make much of a difference, shouldn't really make any difference, as long as the string length stays the same, the period stays the same. We used a metronome, which is on the desk over here, as also an example of that. When I walk my dog around Terra Nova High School up on the hills back there by Sweeney Ridge, you hear the Terra Nova band practicing. And the Terra Nova band, they're practicing outside. You hear this really loud electronic metronome that the band leader is using, of course, to keep everyone in time. And that beat, 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 that metronome, it's really just kind of an inverted pendulum. All they're doing, the one we have in class, is just keeping a regular time. If you want to change the period of a pendulum, you change the string length. And our job, starting Monday and Tuesday, will be, can we make a prediction on the period of any pendulum based on the length of the rope or the length of the string upon which the weight is swinging. That's what we're really after. And so hopefully the students were remembering a little bit of their Galileo. Different objects of different weight fall at the same rate. Well, this is an application of that. If you have a really heavy weight at the end of a pendulum or a really light weight at the end of a pendulum, so long as you control for other factors like air resistance and things like that, it shouldn't make a difference. The mass at the end of the pendulum does not determine the period. The length of the string does. So we're going to jump into that on Monday. Going back to where we began the class, going full circle and talking a little bit about atoms, molecules, and the way they're arranged in a solid. When you look at the steel that made the Twin Towers, the 9/11 towers, it was one of those times when it was a moment that really, for everyone of a generation that remembers that was there, that to turn on the TV or know somebody that was involved with that particular day, it was really a life-changing thing. For myself, and a personal story, I was working at Chevron Corporation at the time in San Francisco. My wife, who is a teacher, she was getting ready to go to school. I was getting ready to go to my job across the bay over in San Ramon. And as I was getting ready to leave, we turned on the TV, we saw the events unfolding on television. I mentioned that because the company that I worked for at the time, Chevron Corporation, had just a few months prior sent me to Boston on a business trip. I had flown back from Boston a few months earlier and on an early morning flight. Now, an early morning flight, unfortunately, is what the terrorists used to hijack, and then they unfortunately flew them into the buildings in New York. When you check out the 9/11 Brain Pop, they do a good job of talking about the events of that day. I mentioned that in terms of what we're learning here, because when you have the potential energy that is in all the gasoline, the jet fuel, that's contained within the wings of an airplane, especially early in the morning when they usually fill up the tanks all the way because that plane will be flying all day, and they divert it, all the potential energy was released at one time. Going back to this screen over here that we had earlier in the talk, when you're talking solid steel, you've got iron and carbon alloy there, you've got steel in a building. When you heat that up, you're increasing the kinetic energy, and unfortunately, in the case of the Twin Towers, the kinetic energy of the atoms and molecules causes them to jiggle even further out of place. In other words, they don't make a nice crystalline solid anymore. They get weaker, and because of the heat that was added to the steel structure, the Twin Towers were not able to support their own weight. When you look at the events of 9/11, it's really important. I know Mr. Westbrook does a fantastic job with this. The events of that day still have implications for almost everything that you see on CNN 10 and in the news today in terms of politics and America's involvement with the rest of the world. So we'll be talking a little bit more about that and why it makes a difference that we know a little bit of the science behind it, why it also makes a difference that we know of events that happened 2 decades ago, because they still impact us each and every day today. Have yourself a nice weekend, and do check out the Brain Pop. I encourage you to, and enjoy your Sunday, and I'll see you back here on Monday, the 13th. Take care.